Hello and welcome to the Quiz 1 walkthrough. Just a reminder, a couple of you did turn in quizzes with little to no work shown. That's not worth any points. If it took me half a page to do it and 15 minutes to do a problem similar in class, and you have literally just the last thing written down, I can't accept that. So make sure you're doing the work and showing the work. If it's just done in a computer, that's, again, not worth any points. So our first one, we're going with converting radians to degrees and vice versa. One other reminder before we get too far into this. The quizzes are still considered proctored. They have to be done during class time. They have to be submitted as soon as class ends. I got a couple, several hours, and I think in one case a day later. I can't accept those. That has to be sent as soon as class is over. All right, so our first one, 5 pi over 3 in radians. We're turning that into degrees. So our conversion factor here, multiplying by 1 in the form of 180 degrees, is the same as pi radians. So the pi's will drop. 180 over 3 is worth 60. 5 by 60 is 300, and the degrees did not drop. The second one, we're converting 145 degrees into radians. 145 in degrees. So then our one this time is 180 degrees underneath pi radians. So let's see. So then by 45, so that's divisible by 5. So look on there. 5 by 29 pi over 5 by 2 by 18. So 29 pi over 36 would be our radians. Second one, arc length. So our radius was 5 meters, and our angle was 7 pi over 6. So for this one, if you are into memorizing formulas, that's fine. If not, your arc length, if we did a full circle, would be pi times the diameter. So pi times 2 times the radius. And then we're looking at what fraction we have out of the full lap around. So we have theta degrees out of the full trip around is 2 pi. So the 2 and pi drop. R times theta is our arc length. So radius of 5 in meters, arc length 7 pi over 6. So this would be 35 pi over 6 in meters. Our third one, then we're looking at finding the area for the previous setup. So radius of 5 meters, an angle of theta is 7 pi over 6. Again, if you're into memorizing formulas, that's fine. That'll work out fine. We have pi r squared would be the area if we have the full circle, and we have theta out of 2 pi of a rotation on there. So the pi's will drop. So r squared theta over 2. So 5 squared times 7 pi over 6 over 2. So 25 by 7, 175 pi over 12. And this would be in square meters, since we're talking area. So 5 meters by 5 meters is what's giving us the square meters there. Okay, so that's our first page of questions. So onwards and upwards. Exact value for the 6 trig functions on theta is 5 pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So 1/2 for the x, negative root 3 over 2 for the y. So sine theta, negative root 3 over 2. Its buddy cosecant theta would be negative 2 over root 3, which is negative 2 root 3 over 3. Cosine theta is the positive 1/2. Secant theta, then the reciprocal of that is 2. 2 over 1 is just 2. Tangent theta, sine over cosine, negative root 3 over 2 divided by 1/2. The 1/2's dropped, so we have negative root 3 over 1, or negative root 3. Cotangent of theta, half over negative root 3 over 2. So the denominators drop, so we have 1 over negative root 3. So negative root 3 over 3. Problem 5, we're looking at the product of the cosecant of pi over 4 with the tangent of 60 degrees. So pi over 4, that is at root 2 over 2, root 2 over 2. (60 degrees) is at 1/2 positive root 3 over 2. So the cosecant is the reciprocal of the sine. So the sine is root 2 over 2, so 2 over root 2. And then we're multiplying by the tangent of 60 degrees, which is the sine of 60 degrees over a cosine of 60 degrees. So we have 2 root 2 over 2 times root 3. The 2's dropped, so this is worth root 6. Problem 6, the exact values of the 6 trig functions given our point on the unit circle. So our point given was root 7 over 3 with root 2 over 3. So cosine of theta would be our root 7 over 3. We're told that this is on the unit circle, so the radius is 1. You can confirm that by just doing x squared plus y squared. You can confirm that does indeed give you a 1. 7/9 plus 2/9 is 9/9. 9/9 is a 1. So secant theta, reciprocal of that, so 3 over root 7, so 3 root 7 over 7. Sine of theta, root 2 over 3. So sine's partner, the cosecant of theta, 3 over root 2, and just rationalize that denominator. So 3 root 2 over 2. Tangent theta, sine over cosine, as always, so root 2 over 3 divided by root 7 over 3. The over 3 is dropped, so we have root 2 over root 7, and then we rationalize, so root 14 over 7. Cotangent of theta, it's just the reciprocal of that, so root 7 over root 2, so that's root 14 over 2. That is page 2. Page 3, the exact value of the secant of 33 pi over 4. So secant is related to cosine, so we're looking to make this as an angle plus 2k pi. So 32 pi over 4 is 8 pi. So 32 pi over 4, that leaves us one more of the pi over 4s. So we have the secant of pi over 4 plus 8 pi, or 2 by 4 pi. So that's the same as the secant of pi over 4. So that's at root 2 over 2, root 2 over 2. So reciprocal of cos is 2 over root 2, which is 2 root 2 over 2, or just plain old root 2. The exact value of the remaining trig functions. So we're told that cosine of theta was negative 2/3 and that sine of theta was greater than 0. So sine of theta greater than 0, we're in either Q1, Q2, or the positive y-axis. Cosine is negative, that pushes us over into Q2. So that's where you'll draw your little rectangle. So our cosine was negative 2/3. So we can think of this as x over radius. So negative 2 over a radius of 3. So we need our y value out of that. So negative 2 squared plus y squared is 3 squared. So y squared is 9 minus 4, 5. So y is root 5. So let's see, we already had the cosine as negative 2/3. So our secant, freebie from that, negative 3/2. Sine of theta, root 5 over the radius of 3, hypotenuse of 3. Cosecant of theta, reciprocal of sine, so 3 over root 5. So 3 root 5 over 5. Tangent theta, sine over cosine, or y over x, so negative root 5 over 2. Cotangent theta then, negative 2 over root 5, which is negative 2 root 5 over 5. Okay, our sketching ones. We're going for y is negative 3 sine of half x. Using transformations. And they want at least 2 cycles on this one. So usual scale, pi over 2, pi, 3 pi over 2, 2 pi, and then we just repeat. So 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. So we'll start with y equals sine x. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2, we're at negative 1. 2 pi, we're back to 0, and the pattern repeats. So there's our 2 cycles on the original. So next we look at what happens if we go to y equals sine of 1/2 x. So remember, inside is working backwards, so times a half is really doubling the x values. So this one I'll go all the way to 8 pi now. So we have our 9 pi over 2, 5 pi, 11 pi over 2, 6 pi, 13 pi over 2, 7 pi, 15 pi over 2, and 8 pi. So what happened at 0 stays at 0, but what happened at pi over 2 is now happening at pi. What happened at 3 pi over 2 is now happening at 3 pi. What happened at 2 pi is now happening at 4 pi. What happened at 5 pi over 2 is now happening at 5 pi. What happened at 3 pi, now it's at 6 pi. What happened at 7 pi over 2, now that's at 7 pi. Which I will put in the appropriate spot this time. And what happened at 4 pi now happens at 8 pi. So our period doubled in length here. And then our final one, the -3. Take your old outputs, multiply them by -3. So 0 times -3 is 0, but 1 by -3 is -3. 0 times anything is 0. -1 by -3 is +3. And so on. So then that's our final stage. Similar problem, but we got to play with some cosines. Okay, so our usual scale for this one, so pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, and 8 pi. So cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi -1, and so on. And our pattern repeats. My apologies. Ignored my own scale there. Okay, so now appropriately scaled. There's our 2 cycles of the cosine. So then we just account for each of the other things done to it. So cosine of 2x. So instead of times a 1/2 inside, now we have a times 2 inside. We have to go half as far. So 0 stays pinned. What happened at pi over 2? Now it's happening at pi over 4. What happened at pi? Now it happens at pi over 2. What happened at 3 pi over 2? Now that's happening at 3 pi over 4. What happened at 2 pi now is happening at 1 pi. What happened at 5 pi over 2? Now that's at 5 pi over 4. What happened at 3 pi? Now that's happening at 3/2 pi. 7 pi. 7 pi over 2 is now 7 pi over 4. And 8 pi is now happening at 5 4 pi. I don't know where I got an 8 pi there. 4 pi. 8 pi is now happening at 4 pi. Or 4 pi is now happening at 2 pi. So this was a vertical compression. And then, let's see, so in black we did just y is cosine x. Blue we did that, so red will do the 4. So times 4, 1 times 4 is 4. 0 times anything is 0. Negative 1 times 4 is negative 4, and so on. And arrows on the end, that indicates this pattern continues. 11, we got to keep playing with sketching graphs. Our goal on this one was tangent of quarter x. So tangent, recall, we're going between typically minus pi over 2 to pi over 2 for our tangent lines. And in fact, let me scooch this one over a little bit. It's a little bit easier if I have a little bit more horizontal room there. Since we're straddling 0 here, I'm going to put my vertical axis a little closer to the center than I typically do for the sines and cosines. All right, so from minus pi over 2 to pi over 2, we've got vertical tangent lines happening there. Because remember, tangent theta is sine theta over cosine theta. Cosine is 0 at pi over 2, also at negative pi over 2. Sine is 0 at 0. And at pi over 4, the halfway mark to these tangent lines, the absolute values are the same. In Q1, they are both positive. However, once we go in our unit circle over to Q2, or my apologies, Q4, cosine is still positive, sine is negative, opposite signs. So we're in negative territory there. So there's one round of it. So then usually I just go to the right from there. So let's see, so that's pi over 2, so then we'll do, here is pi. And we have then 3 pi over 2. So at 3 pi over 2, cosine is again a 0, so we have a vertical tangent line happening there. And again, at pi, sine of pi is 0. And then we have this 1 and negative 1 on the side, halfway between. So there's 2 cycles of it. Now the only other thing we had happening to it was tangent of 1/4 of x. So all of our x values are going to get multiplied by 4. So let's see, so 3 pi over 2, I'm going to have to go all the way to a 6 pi for that. So here's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. So what used to happen at pi is now happening at 4 pi. At 5 pi over 4 is now happening at 5 pi. At 3 pi over 4 is now happening at 3 pi. So we still have the same basic shape. We've just stretched it out quite a bit. So what happens at 0 stays at 0. What used to happen at pi over 2 is now happening at 2 pi. 4 times pi over 2 is 2 pi. Minus pi over 2, again, that's going to go to a minus 2 pi then. There's our pi, 3 pi over 2. Negative 2 pi, we now have an asymptote as well. What happened at 0 stayed at 0. What happened at pi over 4, 4 times pi over 4 is just pi. Negative pi over 4 is this x value, so multiply that by 4 and we're at negative pi. And there's our other stretched out tangent line. 12, we get to start playing with cosecants. Okay, so cosecant, recall, is based on sine. So my first graph is y equals sine x. So a usual scale for sine there. So sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, 3 pi over 2 we're at negative 1, and then we're back at 0 at 2 pi. And then that cycle happens again. So there's the beginning. Then we'll go to the cosecant. So cosecant is a reciprocal. 0 does not have a reciprocal. And so these guys will turn into vertical tangents. Please disregard those two. 1 is its own reciprocal, and then the reciprocal of something very close to 1 below is something very close to 1 above. Reciprocal of negative 1 is itself, and similarly, proper fraction turns to improper fraction. And then our last stage, negative 2 is on the outside, so multiply our old outputs by negative 2, which means this guy will start at a negative 2 instead of a positive 1, and it'll still be changing rapidly. This guy started at negative 1, now he'll start at positive 2. The tangent lines stay where they are. 13, we got to play with just a little phase shift. Y equals 3 sine of x plus pi over 4. So this one I'll just start with y equals sine of x as usual. Same scale we've been using for the sine. So this time, this plus pi over 4. All you have to do is think back to your college algebra days. So we have a plus inside. Inside works sort of backwards. So instead of moving positive pi over 4, it's going to move everybody left pi over 4. So we just picked up the black graph, slid it to the left, pi over 4. And our last one, times 3 outside. This was at 1, now it's at 2, 3. This was at 0, it stays at 0. This was at 0, stays at 0. This was at -1. -1 times 3 is -3. So then there's our final version. Okay, so then 14, we're done playing with the graphs. Arc cosine of -√3 over 2. So cosine, remember that is the top half. And so we're saying -√3 over 2 for our x value. So we're talking about right here. So this is a multiple of the pi over 6. So 1, 2, 3, 4, and 5 pi over 6. Uh, 15, similar idea. This time the arc sine of -√3 over 2. So on this one, they were hoping that you remembered that the sine is from minus pi over 2 to plus pi over 2. So this time our sine value is -√3 over 2. So this is one of our multiples of 60 degrees. It's 60 degrees backwards, so theta is negative pi over 3. We're looking for an exact solution. We have 4 arc sine of x is worth pi. So arc sine of x is pi over 4. So the sine of the arc sine of x is the sine of pi over 4. So x is the sine of pi over 4, so √2 over 2. Uh, 17, we're looking for the arctangent of √3 over 3. So then if theta is the arctan of √3 over 3, tan theta is tangent of the arctan of √3 over 3. So tangent theta, root 3 over 3. So they're asking what angle has a tangent value of root 3 over 3. So remember, this is equivalent to 1 over root 3 or 1/2 over root 3 over 2. So our y value was 1/2. Our x value was root 3 over 2. That is a pi over 6. All right, so 18, we're working with kind of the limitations of the doing the sine of the arc sine. B in 17 was actually an accidental repeat. You've already seen that one before. Uh, 18, so the arc sine of the sine of 11 pi over 4. So remember, sine, we're working with minus pi over 2 to pi over 2. So 11 pi over 4, so here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So here is 11 pi over 4. That is outside of where we want the sine to be, but its equivalent would be here in Q1. So this is the equivalent of saying we have an angle of pi over 4. So 19, find the inverse of the function given and find the domain and range of the inverse. So our given function, f of x, was 5 sine of x plus 1 minus 3. So then y was 5 sine of x plus 1 minus 3. So our inverse, x and y trade roles, so x is 5 sine of y plus 1 minus 3, so x plus 3 all over 5 is worth the sine of y plus 1. So the arc sine of x plus 3 all over 5 is y plus 1, so y is arc sine of x plus 3 all over 5 minus 1. So that is our f inverse of x. So the domain of the original, negative infinity to infinity, so that is now the range of the inverse. The range of the originally just a y equals sine x, we're stuck between -1 and 1. Times 5, now we're at -5 to 5, and drop it down to 3. Oh, down 3, my apologies. -3, so we would drop down 3, so -8 to +2. That is now our domain. We could also have gotten the -8 to 2 using the fact that the domain for this inverse function, we had to be stuck between -1 to 1 and just solving it by clearing the fraction and adding 3 to all three sides of the inequality. Whichever way works for you. All right, so 20. And 6 arc sine of 5x is minus pi. So arc sine of 5x is minus pi over 6. So take the sine of both sides. And 5x is the sine of minus pi over 6. So 5x, the sine of minus pi over 6, would be a -1/2. So x is -1/10. And let's see, those are no restrictions on that guy. 21. Now we're solving on 0 pi, 0 to pi. So 3 minus 4 cosine squared theta is 0. So 3 is worth 4 cosine squared theta. Cosine squared theta is worth 3/4. Square root of both sides, so cosine theta is plus or minus √3 over 2, so square root of 4 is 2. So anywhere that the cosine theta is either √3 over 2 or -√3 over 2 on 0 to 2 pi, so it's at pi over 6. It is at 5 pi over 6, 7 pi over 6, and 11 pi over 6. So 4 values on 0 to 2 pi, that would make that one happy. Uh, 22. Again, we're stuck on 0 to 2 pi. So we have sine of 3 theta plus pi over 5 is equal to 1. So we take the arc sine of both sides, and 3 theta plus pi over 5 is worth the arc sine of 1. So the arc sine of 1 is at pi over 2 plus any number of multiples of pi you want. So just think of your unit circle. We're at right up here. So 3 theta plus pi over 5 is worth pi over 2 plus 2k pi. So pi over 2 plus 2 pi plus 4 pi plus 6 pi, etc. So then 3 theta, pi over 2 minus pi over 5 plus 2k pi. So theta, so this is 5 pi over 10 minus 2 pi over 10, so 3 pi over 10 plus 2/3 k pi. Okay, so if k equals 0, theta is 3 pi over 10. That's on our given interval. Recall our theta here was on 0 to 2 pi. K equals -1, knocks us out of contention though. Theta would then be 3 pi over 10 minus 2 pi over 3. That kicks us into negative territory. K equals +1. Theta is 3 pi over 10 plus 2 pi over 3. So that's 23 pi over 30. No, yes, yeah. 20, let's see. Or let's just do it in 2 steps. So 9 pi over 30 plus 20 pi over 30. So 29 pi over 30, definitely under 2 pi. K equals 2. Theta is then 3 pi over 10 plus 2/3 k pi, 2 by 2, 4 pi over 3. Common denominator there of 30, so 9 pi over 30 plus 40 pi over 30, so 49 pi over 30. That's still under 2 pi, so we're happy with that. K equals 3, however, theta is 3 pi over 10 and then k equals 3, the 3's drop, so plus 2 pi. So I have a positive plus 2 pi that is greater than 2 pi. So the ones that we get to keep, so theta could be 3 pi over 10. Theta could be 29 pi over 30. And theta could be 49 pi over 30. Those are the guys we would get to keep on 22. 23. We're looking for the general form. So cosine of 4 theta is negative 1/2. So we'll take the arc cos of both sides. So 4 theta is the arc cos of negative 1/2. So arc cosine of negative 1/2. So arc cosine, we're at the top half of this. And arc cosine, negative 1/2. So that is 2 pi over 3. So 4 theta is 2 pi over 3 plus 2 times k times pi. So theta pi over 6 plus k pi over 2. And 24. We're solving this one. We need a property. So we have sine of theta plus 1 is 2 cosine squared theta. So this one is quadratic. We want to write it in terms of sine only. So recall sine squared theta plus cosine squared theta equals 1. So sine of theta plus 1 is 2 times 1 minus sine squared theta. So sine theta plus 1 is 2 minus 2 sine squared theta. So 2 sine squared theta plus sine theta minus 1 is 0. So this is like a 2u squared plus u minus 1. Equals 0 kind of situation. So that's factorable over the integers. At least our pretend guy is. So 2 sine theta with sine theta will give us 2 sine squared theta. Let's see, we're multiplying to a negative 2, adding to a positive 1, so I need a plus 2 and a minus 1. We're still equal to 0, so sine theta is 1/2, or sine theta is negative 1. So sine theta being a half, where does that happen? So sine theta being at half, that will happen at sine is half, so here and here. Sine theta being -1 will happen down here. So theta is at pi over 6, or 5 pi over 6, or -1, 3 pi over 2. Now this one, had I just stuck with cosine u equals -1/2, we also could have included in this then a 4 pi over 3. Plus 2k pi, which would then also give us the possibility that theta was pi over 3 plus k pi over 2. Okay, so that's your quiz solutions. So practice, practice, practice. Get to know that unit circle if you haven't learned that one yet. Make sure you know how to quickly send me the files. Remember, I do not accept them if they're sent hours and hours later. When class is over, I have to get those files into my email. So good luck. Make sure you're spending that time working on preparation for the test, and I will see you on test day. Thanks, everyone.